Well, this is example number 1 dealing with kinematics, and we're throwing gravity in there. It's not a huge jump from just using the kinematic equations to using ones with gravity. Gravity actually makes it a little easier because we automatically know our acceleration. We just have to think about whether it's positive or negative. So if I read this question, the first thing it asks, it tells me that I'm going 350 meters, and I want to know how long it takes the rock to fall. So I know some stuff, I can assume some stuff. That's the hardest part about these questions, is thinking about what you can assume. Now, the distance is super easy. That's not assumed. It's going 350 meters. I have to assume that it's going to speed up, and it's going to speed up due to gravity. Now, I'm ignoring air resistance. I admit air resistance might slow a rock down going this far. However, we can't do that quite yet. We're saving that for our university profs to figure out and show us. So we are just going to assume it does not have any air resistance at all. The other thing I can do is think about if I drop something, when I drop it, it starts from rest. It starts off with a velocity of 0 because I'm not throwing it down, I'm dropping it. That's really important to realize. Without that piece of information, you would have been sitting here staring at this question, probably cursing me for a while. This now lets me figure out the thing I need to know, which is the time. I want to know how long does it take. Now it's just like any other kinematic equation question. I'm going to pick my equation that works the best. I'm going to substitute my numbers, and I'm going to solve. So remember, 0 times anything is, I put a plus where there should be a equals. So 0 times anything is 0, and then I can put these in. So plus 1/2. My a is going to be 9.8 because it's going to speed up as it falls. It's positive, and then t squared. Excellent. I'm going to simplify because this 0 plus anything is itself, so the 0 goes away effectively. I got 350, and I'm going to find half of 9.8. I keep doing that. Obviously, I'm tired. Okay, so 4.9 is half of 9.8 t squared. Excellent. So I'm going to first divide the 4.9 over because it's multiply on this side. It'll divide to the other. So 350 divided by 4.9. Remember, we don't have to write this all down. I'm just writing it down for the sake of people that are doing this in their calculator. They can follow along and feel confident they know what they're doing, or for those that need to write it down. Okay, so we've got this in my calculator. It's a big long number. I'm just going to leave it in my calculator. I'm going to keep extra digits if I write it down, though, because it is important I don't overround. So I've got this. And now, if this is squared, to find the answer, I need to square root. I need to find the square root of this number. So that's what we'll do. We'll find the square root of 71.428. I think it was 5, etc. So I just did something weird. Square root of 71.428. It doesn't help if you put it in your calculator incorrectly. There we go. So I got 8.451, etc. When it comes to sig figs, 9.8 does count. So I'm going to include it so I can only have 2. So I'm going to have 8.5. And that's because, remember, 9.8 is a rounded number. It's actually slightly different everywhere in the world because of this distance from the center of the earth. But it does all round to 9.8, which is why we use that number. Okay, there you go. Part A. We'll come back and do part B in the next video.